Okay, now we have lesson 5-5. It's called standard form. It's the last of our forms of types of linear equations. So we got two objectives here. We want to be able to graph linear equations using intercepts and then write linear equations in standard form. This getting ready box helps you kind of just think about what we're going to be doing in this lesson with intercepts and writing equations in standard form. So it says an athlete wants to make a snack mix of peanuts and cashews. So, maybe make this pink. Peanuts and cashews. That will contain a certain amount of protein. Cashews have 4 grams of protein per ounce, and peanuts have 7 grams of protein per ounce. How many grams of protein will the athlete's mix contain? What do the points 7, 0, and then 0, 4 represent? So, you should be pretty familiar with y-intercepts. Anytime you have an ordered pair 0, something, that's the y-intercept. So if you look, they graphed peanuts on the y-axis and cashews on the x-axis. Now, this isn't, these aren't independent and dependent variables. When we do this lesson and when we start writing these kinds of equations, it's not like the ounces of peanuts depends on the ounces of cashews. It's kind of like more of like a correlation between the two. So, what they're going to start doing is they're going to write equations. So let's say that P stands for peanuts and C stands for cashews. We're going to have this equation. Cashews have 4 grams of protein per ounce. So we're going to have 4C. Now, if we're making a mix, we're going to add in the peanuts, plus peanuts have 7 grams of protein, plus 7P, and then that's going to equal something. Okay, so whatever they want their mix to total, it's going to equal that number. So if we have, now, then it says, how many grams of protein will the athlete's mix contain? Well, it all depends. If I have 2 ounces of cashews, it's going to be 4 times 2, and if I have maybe 2 ounces of peanuts, plus 7 times 2, that's going to be 8 plus 14, which is 22. Okay, but there's different situations. You could have 3 ounces of each. So we'll get to that more, but it says, what do the points 7, 0, and 4, 0 represent? What that means is you could have a mix. So this one right here, 7, 0. What that represents is that you have 7 ounces of cashews and 0 ounces of peanuts, because cashews is on the x-axis and then peanuts is on the y-axis. And then this one, the y-intercept, and this is called the x-intercept right here, 7, 0, because it's where the graph crosses the x-axis. And then 0, 4 means I have 0 ounces of cashews, but I have 4 ounces of peanuts. So you can see how we're going to, instead of like finding the y-intercept and then using the slope, this chapter doesn't use slope at all. It just graphs equations by finding 2 points, 2 intercepts, and then drawing a line between the 2 intercepts. Okay, so this is what standard form is. Definitely write this down. This is very different from all the other ones. It's ax plus by equals c. And it doesn't matter if the letters are capitalized or not, but the book has them capitalized, so I just capitalized them here. Now, a, b, and c are just real numbers, and they don't equal 0. If they equal 0, then they're special cases, and I'll show you that. But it's not like a is the slope and b is the y-intercept. They're really just regular numbers. So you cannot figure out slope from standard form. You can figure out the x-intercept and the y-intercept. You can figure them out, but they're not given to you in the equation. Okay, so if we need to find the x and y-intercepts, it says, what are the x and y-intercepts of a graph? I'm just going to show you a picture over here. Anytime you have a y-intercept, so here's our y-axis. These lines all go through the y-intercept. They all have the formula, or the ordered pair, 0, like this would be 2, this would maybe be 5, and this would maybe be 9. So y-intercepts are always of the form 0, number, because the x value is 0, and then the y value is wherever it crosses. Now, x-intercepts go through the x-axis, and I guess they could go through over here too. So if we're plotting these points, this would be like 1, 0, this is maybe 4, 0. This over here is maybe negative 3, 0. Because ordered pairs, there's always the x value always comes first, and then the y value comes second. But if you're still on the x-axis, then the y value is going to be 0 because you haven't moved up or down at all. So x-intercepts always have the form number, comma, 0. Okay, that's really important. So if we need to find the x and y intercepts, if you're trying to find the x-intercept, you're going to substitute in y, you're going to substitute y as 0. Now, if that gets confusing, just think, like, if I need the x-intercept, I need to solve for x. So the other variable, the only other variable I have, y, has to be 0. So to find the x-intercept, we use this equation, 3x plus 4, and then we're going to multiply it by 0, and we're going to get 24. So 4 times 0 is 0. We have 3x equals 24, divide both sides by 3, and we have x equals 8. So the x-intercept is 8. Now, if we want the y-intercept, from other kind of formulas, it's easy because it's just in the formula. But you actually have to solve for it if it's in standard form. So all of these y-intercepts over here all have the form when x equals 0. So we're going to plug x equals 0 into the equation. So we're going to have 3 times 0 plus 4y equals 24. So 3 times 0 is just 0. We have 4y equals 24. Divide both sides by 4, and we have y equals 6. So your y-intercept would be 6. Okay, and standard form is the easiest to do this in because you'll see, like, when you multiply by 0, this piece is going to cancel out, and you just have 4y equals 24. And when you're finding the x-intercept, this piece cancels out. So these equations are really easy to solve for intercepts. And then if we had to graph this equation, we would just plot those 2 points and then draw a line between them. Okay, so let's do one more of them. Again, if you need the x-intercept, that's when y is equal to 0. If you need the y-intercept, that's when x is equal to 0. Okay, so let's see. X-intercept, we're going to make the y value 0. So we have 5x minus 6 times 0 equals 60. So 6 times 0 cancels out. We have 5x equals 60. Divide both sides by 5, and we get x equals 12. So the x-intercept is 12. To find the y-intercept, we're going to plug in 0 for x. So we have 5 times 0 minus 6y equals 60. 5 times 0, that's gone. So we have minus 6y equals 60. Divide both sides by negative 6, and we get y equals negative 10. So our y-intercept would be negative 10. So from the very beginning, this is in standard form right here. 5x minus 6y equals 60. So this is ax plus by equals c. So a is 5, b is negative 6, and c is 60. They literally are just 3 random numbers. None of them is the slope. Neither of them is the y-intercept. So they're just 3 random numbers that come from some kind of word problem, and you use this kind of form to find the x and y-intercepts. Okay, so if we have to graph this equation right here, x minus 2y equals negative 2, we could put it in slope-intercept form, and we could graph it that way, or we could find the x-intercept. So let's find the x-intercept. That's when y equals 0. So we have x minus 2 times 0 equals negative 2. 2 times 0 cancels out, and we have x equals negative 2. So the x-intercept, where this line is going to cross the x-axis, is right here at negative 2. Okay, now find the y-intercept. That's when x equals 0. You kind of picking up if it's the x-intercept, the other variable y is 0. If it's the y-intercept, the other variable x is 0. So this time we have 0 minus 2y equals negative 2. So 0 cancels out. We have negative 2y equals negative 2. Divide both sides by negative 2, and you get y equals 1. So the y-intercept is 1. So then you just draw a line between those 2 points, and that's your equation. Okay, that's it. Alright, one more like that. So what's the graph of 2x plus 5y equals 20? Let's find the x-intercept. That's when y is equal to 0. So we have 2x plus 5 times 0 equals 20. 5 times 0 cancels out. We have 2x equals 20. divide both sides by 2, x equals 10. Now, when we do this in class, I'm going to kind of show you. It's hard to show you on here because I can't actually show you covering it up with my hand. But if you think about it, if y is going to be 0, this whole piece is going to cancel out. So really all you have left is 2x equals 20. But I'll show you that in class. So let's see. The x-intercept would be somewhere out here. Let's just say this is 10. Okay, and then y-intercept, that's when x is equal to 0. So we have 2 times 0 plus 5y equals 20. 2 times 0 is 0. 5y equals 20. So divide both sides by 5. And y is equal to 4. So we come up to 4 on the y-axis. And then we have 2 points. We can just draw our best straight line through those 2 points. And then that's the graph of the equation. Okay, there's 2 special cases. So you have, this is standard form, ax plus by equals c. Well, if a happens to be 0, then you're going to have 0 times x plus by equals c. And 0 times x is going to cancel out. So they're not actually going to give it to you as, like, you're usually not going to see something like this, like 3y equals 5. It's going to already be solved for y, so they'll already give it to you after they divided by 3 or whatever. So they're going to give you equations that look like this. Y equals 6, y equals -2, y equals 10. Those are all horizontal lines because all you have, if y equals 6, you come up to 6, 1, 2, 3, 4, 5, 6, on the x-axis, and it says y equals 6. So y is always equal to 6. If I move over 1, it's still equal to 6. If I keep moving over, if I move over this way, it's still equal to 6. So that's going to be a horizontal line. If I have y is equal to -2, I'm going to come down here to -2, and the y value for every single ordered pair will always be -2. So that'll just be a horizontal line. The opposite, if b equals 0, so I have ax plus b times 0 equals c. This is going to cancel out, and I have ax equals c. Again, they're just going to give it to you like this. X equals 5, x equals -1. Now those are going to be vertical lines, because if I go over here on the x-axis to 5, it says x is always 5. So x is 5. Even if I move up, the x value is 5. If I move down, the x value is 5. Like if you were to make a table, an xy table, x is always 5. So 5, 5, 5. Pick whatever ordered pairs other y values you want. X is always 5. So it's going to be straight up and down on x equals 5. So these are equations in standard form, but they're either going to be missing the a piece or the b piece, but it's still standard form. Okay, so let's just do these. X equals 3. So we come on the x-axis to 3, and it's just a straight line up and down through the x-axis at 3. Y equals 3. We're going to go to the y-axis at 3, and it's just a straight line going through 3 on the y-axis. If we have x equals -1, we're going to come to the x-axis at -1. I missed it just a little bit, but it goes through -1 on the x-axis. And then over here, y equals 0. Well, if it's y equals 0, you have to make sure it goes through the y-axis, which is going up and down. So I'm going to get rid of that because I don't want that. If it's y equals 0, it has to be going this way through 0, because anything that's y equals is always horizontal. Okay, and the last part of this, probably the hardest part, is transferring something into standard form. So if they give you this equation, y equals -3/7 x plus 5, and they want you to write it in standard form. Now this using only integers is because you could change everything to decimals and have a whole bunch of decimals, and it's really tough. But if you only want to have integers, well, that means we can't have fractions. So the only fraction I see is -3/7. So to get rid of the divide by 7, I need to multiply this side by 7, and I need to multiply this whole side by 7. So over here, 7 times y is just 7y. Now, if I have -3/7 times 7, the 7's are going to cancel out, and I'm just going to be left with -3x. Then if I have 7 times 5, that's 35. Now, it's not standard form until it looks like ax plus by equals c, where you have x and y on the same side. So to get x and y on the same side, I just need to add 3x to both sides. Now, if 7 has a y and 3 has an x, you can't combine them, but you just write them as two separate pieces. So I have 7y plus 3x is equal to 35. And so these are the same two equations, just one is written in slope-intercept form and one is written in standard form. Okay, we'll try another one of those. So this one is in point-slope form. So we have y minus 2 equals negative 1/3 x plus 6. Alright, if you have parentheses, the first thing you should probably do is distribute. So I'm going to keep this y minus 2, and I'm going to take negative 1/3 times x, which is negative 1/3 x, and then negative 1/3 times 6. Now multiplying by 1/3 is the same as dividing by 3. So 6 divided by negative 3 would be negative 2. Okay, now if I'm going to go through and multiply everything by 3, just like I did on the last one, because 3 is my denominator, it's going to make you're just going to have more pieces. So I might as well, like, this is a regular number and this is a regular number. So I can combine those. But if I want to have it look like this, ax plus by equals c, I want the numbers over here. So I already have a number over there, so I'm going to add 2 to both sides, and that'll cancel out these. So I'm going to have y equals negative 1/3 x, and then negative 2 plus 2 is just 0. Okay, so now I still need to clear out the fractions, so I need to multiply both sides by 3. So multiply this side by 3, and multiply this side by 3. So I have 3y equals, now 1/3 times 3 would just cancel out. That would be 1. But because it was a negative, I still have negative x, but the 3's cancel out. Now, to get standard form, I have to have x and y on the same side, so I'm not done. I still have to add x to both sides. You can't combine 3y and x, so just leave them as two pieces. 3y plus x equals, now it has to equal something. There has to be something left over there. So if the numbers have all canceled out, technically negative 2 plus 2 was equal to 0. So we just have 3y plus x is equal to 0. And that would be written in standard form, and it's only integers, no decimals. That's definitely the toughest, so we will practice a lot of those tomorrow. Okay, and the last part of this, what this is used for the most is actually modeling situations. So we have a media download store sells songs for $1 each. So songs are $1 each, and movies for $12 each. You have $60 to spend. Write and graph an equation that describes the items you can purchase. And then the second part we'll get to later. So we need to make an equation. So we need to define some variables. So S equals songs and M equals movies. Now, one of these isn't independent and one of them isn't dependent. They're just two separate variables. But if we have $60 to spend altogether, it's $1 for each song, plus it's $12 for each movie, and if we add those two together, it's going to equal $60. So think of some situations. If you don't get any movies, so let's say movies equals 0. That means this piece right here is equal to 0. And you have 1s equals 60, so you can get 60 songs. If songs is equal to 0, then you have this 12m piece, but you don't have the 1s. So you have 12m equals 60, divide both sides by 12, and you can get 5 movies. Okay, and then any sort of combination in between there you can also get. So here's your equation, 1s plus 12m equals 60. Now if we're going to graph this, now it doesn't make sense to have negative numbers, so instead of making a coordinate plane, I'm just going to make one of these L's because all we have is positive and negatives. And because one isn't independent or dependent, it doesn't matter what goes on which axis. So I'm going to put songs down here, and I'm going to put movies up here. Now, we got to figure out what the x and y intercept are. So if we have 1s plus 12m equals 60, if we make movies equal to 0, which we did over here, you can get 60 songs. So the x-intercept is going to be 60. If we're just getting songs, 0 movies, we have 1s equals 60, we can get 60 songs. If we're just getting movies, we can get 5 movies. So if I come up here to 5, I can get 5 movies. Now if I take a line and connect those 2 points, any of these combinations would work out to be $60. So I don't know exactly what they all are, but let's say this is like, like 10 songs. 10 songs goes with a certain movies amount. It might not, that might be a bad example because it might not be a whole number, but any point on this line, you could get movies and songs. The 2 intercepts is just strictly songs right here, and then just movies right here. So then it says, what are 3 combinations? Well, we already know that we can get 60 songs and 0 movies. That's one combination. We could get 5 movies and 0 songs. And then any other point on this graph, so I'm just going to say, let's see, if I get 2 movies, so that means I have 1s plus 12 times 2 movies equals 60. So 12 times 2 would be 24. So I have 1s plus 24. Subtract 24 from both sides. So I have 1s equals 36. Divide both sides by 1. So s equals 36. So there's another combination. I can get 2 movies and 36 songs, and that would equal $60. So this is mostly where we use standard form, and these kind of equations are going to be really, really big in chapter 6. Okay, if you look on page 325, there's a concept summary box. It kind of shows you all 3 forms we've done: slope, intercept, point, slope, standard form, all graphed on one graph, and it kind of gives you the same equation, just 3 different ways. And then check out the lesson check on page 325, and we'll go over those tomorrow.